We actually have laptop computers now that are, well, just 5 years ago, I would have been stunned that I could have a gig, you know, of hard drive storage space. So I will get back to that. But we've already, Bob Poole, as you can tell, we do share some of our information and slides. So Bob has already talked about how congestion is growing. One point I will make, though, congestion is growing across the board. This is Texas Transportation Institute data looking at 1982 and 2003. But even in small urban areas, congestion is increasing. Bottom line here is the trend is going the wrong way. And Bob mentioned earlier that the transportation improvement plans, even if they're implemented, don't get you to a reduction in congestion. They focus on slowing the rate of growth in congestion. And the problem with that, as you mentioned before, is that we're going from a period where in really the most, only one city, I'll be a little more specific about what this data means. In 1982, Los Angeles was the only urban area or metro area that had congestion that was equal to 40 hours per week per traveler on average. So in other words, 40 hours per year. So in other words, that was the only metro area where on average travelers were wasting a week in traffic, stuck in traffic. By 2003, we had 25 metro areas that were in that, and that we're going to be adding another 11 at least over the next 15 or 20 years. And we're not talking about just big metro areas. We're talking about Portland, Oregon. We're talking about, well, Charlotte's already there. Charlotte's not that huge it's not a huge metro area. It's a big one, but not a huge one. Sources of congestion, we've already talked about what some of these might be. Choke points, intersections where you've got a lot of cars and trucks just trying to get from one place to the other. Lane narrowings, accidents, weather, these are all important factors. We tend, in the lingo of congestion and transportation planning, we tend to break out two different sources of congestion. Recurrent, which is ongoing chronic congestion, and non-recurrent, which is if you have a thunderstorm and the road's flooded over and you've got traffic backed up because people can't get through the water, the flooded area, or a tree falls, or there's a car accident. It's temporary, it's independent, generally. And for the most part, what we find is that about half of the congestion is recurrent and half of it is non-recurrent. So, but separating them two can sometimes be a little tricky because what you have when you have an accident, very often you have accidents in very congested parts of the network. So you get a lot of cars are slowing down, people are trying to get from one lane to the other, that type of thing. But nevertheless, these are all sources of congestion. Well, the problem with congestion, as we mentioned before, I'm just going to push this because it's the first time in a presentation I've been able to I have a circle that I can construct. So we'll just move on. But the bottom line is the evidence shows that this is important. I call this balkanization. What congestion does is it balkanizes a metropolitan area, which means that if it takes you, in planning, there's what's called the law of constant travel time. People will make whatever adjustments they need to be about 30 minutes away from where they work, from where they live. And if it's going to be longer than that, for the most part, they make an adjustment. They move or they change jobs. Or they do what I do, which is telecommute. Now the problem is then, if you've got a metro area where to get from southern Atlanta to northern Atlanta takes you an hour and a half, that means what you are essentially doing is creating separate urban cities within that metro area. And they begin to function independently and autonomously. And so I call that balkanization, because you're literally creating these little Atlantas or these little metro areas. The problem with that is today's economy is based on broadening and integrating from as wide of a pool of labor as you possibly can. Being able to transport people and goods as quickly as possible over large regions. Thomas Friedman has a book called The World is Flat. It talks about how technology has changed that. That if we want to develop new software, we can contract with a programmer in Bangalore, India, and they come up with really cool stuff. In fact, a lot of the software that drives a Palm Pilot was developed by Indians in Bangalore. So to the extent that we're actually pursuing policies that balkanize our metro areas, that puts us at a competitive disadvantage, not only within the U.S., but also globally. So I'm very concerned about this as an urban economist, as somebody who loves cities, because I don't see how our cities can remain competitive if we are balkanizing, we are letting congestion balkanize our metro areas. So what do we do about this? Actually, again, Bob went through this, so I'm going to not spend any time on it. We've actually got some numbers, we've got solutions. Most of the current solutions are in the area of what's called demand management, which is getting people out of cars, or just making it costly, or well, the good part of demand management is when you actually try and use your existing road capacity more efficiently. That's not a bad thing at all. But I'm surprised when I'm reading many of these transportation improvement plans how much of it is trying to get people out of their cars. And the problem is that, as a practical matter, it doesn't work. Second of all, I think it actually reduces our quality of life. Because what the automobile really is, it's customized travel. And the whole, essentially, by having a car, I can decide when I'm going to go, where I'm going to go, who I'm going to travel with. And I can tailor those trips to very specific needs. And it's a lot easier to do that with an automobile. And I can't do that when I'm using transit. Now, I'm not going to, this is not a transit presentation. I do think that there are viable, very viable functions of transit. But when we're talking about regional traffic congestion, the practical effect of transit is going to be fairly small. That's just looking at numbers. There's also a mantra that's emerged in transportation planning, which we can't build our way out of congestion. And frankly, what we're finding at the Reason Foundation, and what I spent a big chunk of the last 12 months is actually trying to get at what the academic literature actually says about that. These are some of the current solutions: transit, traffic signalization, ramp metering. I should say that in many ways that almost every one of these solutions are, well, there is no silver bullet in a sense, but every one of these strategies can be useful in the right context at the right time in the right place when it's asked to do the right thing. That's a real, but that in itself is a real challenge. But the bottom line is, and I'm just going to be real short on this because I want to get into what I think the meat of what I want to talk about. I'm convinced, after looking at the literature and looking at individual case studies, that we can build our way out of congestion. In fact, we did it. We did it very cumbersome and very inefficiently when we built the interstate highway system. But we essentially eliminated in the vast majority of metro areas congestion as a meaningful impediment to mobility. But that has been reversed, as we talked about. And I think Houston actually provides a very interesting case study where, and it's actually, you can see where the capacity additions correlate with improvements in mobility or the reductions in congestion. What we have here is the new freeway lanes added. Goes up, and then you have the delay per peak traveler. It goes down. They stopped building in the early 1990s, and you find it goes the other way. Now, another very important and interesting aspect of Houston's solution is not only did they add capacity, but their transit actually did better. They actually were able to attract more people onto transit during that period too. So there's another sub-theme which I'd love to explore, but I don't have time. But just because we're adding capacity doesn't mean that transit is less viable. In fact, if you do it the right way, they should be able to complement each other. And if, in fact, transit is really adding meaningful mobility, there's a demand for it. Bottom line, we can build our way out of congestion. In most cases, I think we have to build our way out of congestion. But there's a right way and a wrong way to do that, which is a lot of what we're trying to focus on at the Reason Foundation. Because I don't think, and we are not going to advocate doing another interstate highway system where you just basically lay asphalt and really see where things fall or where people drive. The real issue is building the right capacity in the right place at the right time. And there are lots of places where you have unused capacity, which we just need to use more efficiently. And the key is to figure out where that capacity needs to be. This, by the way, is a diagram from the reversible elevated expressways in Tampa, Florida, where it's a hot lane, so it's a managed lane, which means it's tolled, and it's funded, large part of the function comes from tolling. So I couldn't get a real picture. It's actually open. It just opened, I think, last month. But they essentially were able to elevate it, add lanes, get people in and out as a major congestion reliever. I haven't driven on it yet, but Bob Poole says it really is cool. So it probably is. But yeah, so what we need, the thing is, we need to think differently about how we actually add this capacity, which means, and which is why I'm in the local transportation planning workshop, we need to think differently about how the transportation network works within a region, an urban region. The old system was really based on wagon wheels and trusses. What do I mean by that? Well, I think one of the best examples is right here, Atlanta. You'll notice that you have a beltway, and then you have these major roads that go into a central city core or the hub of the wagon wheel. This is, in a sense, becomes a rim, and then these are the spokes that all come down into the metro area. And it's really remarkable when you look at metro areas how they are designed around this. And by the way, there's some historical reasons for that. So I'm not even saying that we designed this inefficiently. It was very efficient for the time in which these transportation systems developed. But the problem we have now is our travel patterns have changed. We no longer travel on a hub and spoke. In fact, this is Alan Pisarski, who's probably one of the nation's leading experts on commuting patterns, has tracked this data. Unfortunately, Transportation Research Board has yet to publish Commuting in America 3, although Alan has been promising me for almost 9 months it's about to come out. But he still graciously allowed me to use all his graphics and his data. I have to cite him, but I can't cite the TRB study because it's not out yet. So anyway, but Alan, what he did is he's looking at, this is county level data, which has problems in themselves, but the pattern is important. What we're finding is that these numbers actually translate pretty well into percentages. About 40% of our commutes are suburb to suburb. About 17% of our commutes are suburb to central city. Now, that's the traditional one. Interestingly enough, about 8%, about half of the commutes that are going to the central city, about half of them are actually going to central city suburb, the reverse commute. We've got a lot more central city to central city, metro area to metro area commutes than we ever had before. We actually have 25% of these commutes are actually within central city counties themselves. Basically, we have a very dynamic, very complex, very decentralized travel behavior. This is just commuting. We're not talking about all the other trips that we make to the doctor's office to pick up our kids. I don't register on this because I'm a telecommuter, but I make lots of trips to pick up my kids at school, to take them to soccer practice, whatever it might be. So we need a new kind of network. The hub and spoke system, it works great if you're doing this, but not so great when you're doing this and a lot of that. And David Hartkin has done some great work in North Carolina to actually show how travel patterns have changed in terms of cross-county versus inter-county. So this pattern is actually fairly consistent. Now, let's get to the engineering concept, which I'm sort of learning a lot of this, but where I got to the subtitle of this, trusses and circuit boards. Well, what's fascinating to me is when going back, I love going on old bridges, mainly because I like the architecture. It just sort of gives me a really cool feel. I got all the beams and the angle iron going in. But then I was talking to an engineer and trying to figure out how we can reconceptualize this. And she introduced me to this notion of force and load-bearing joints and beams. And what they found in engineering is that on a bridge, this is a very simple bridge. I actually got this off a website if anybody wants to sort of deal into this in depth. And on lots of bridges, you have beams and angle iron and other things that are what are called zero force. They don't really hold anything. They don't do anything. And in fact, where the force is on this is really at these points there, and they actually carry loads. And so you really don't need all of that infrastructure to actually, for the bridge to actually function and do its job effectively. You've got a lot of extra steel and iron that's actually being developed. The problem we have now is that our current network uses a lot of what I call zero-force roads. We have a lot of roads that just don't carry nearly as much traffic as they can or should, or they are not actually part of the network in a way that makes them efficient. And again, I think Atlanta is very interesting in this regard. One of the things that Wendell, Cox, and Allen have talked about extensively is how dysfunctional the system of local roads in Atlanta is. In other words, you've got all these little roads, and actually it's fairly underbuilt, but they're not connected in an integrated way in a lot of these major trunk roads and lines. And so you really don't have a very efficient way to move traffic. You actually, the freeways, according to, even though they're congested, work reasonably well, but the local roads don't work very well at all. In fact, interestingly enough, Los Angeles is the opposite. Los Angeles' local roads move a stunning amount of traffic, and it's really quite extraordinary. Most of the congestion of the freeway has a lot to do with capacity. So what does this mean, actually? I like this because our current network in many places is inefficient and congestion-inducing. Or again, remember, most of these transportation networks are road-based networks. So I'm saying the road-based network we have in these metro areas, given our existing economy, given the way we travel, is inefficient and is congestion-inducing. We need to think differently about this. How do we think differently about it? Okay, good. Well, I like to think in terms of spider webs and circuit boards. I think in terms of how do we manage the flow. And I began thinking more in terms of, rather than a wagon wheel, let's think more in terms of a spider web. Now, a spider web serves two functions. One, it traps its prey. I'm not that concerned about trapping the prey in this case. What I am more interested is how the spider gets across the web in order to get to the prey. And a spider web really has a very fine network of connections in the web that allows it to travel large distances for its size very quickly. And it does it by creating lots of nodes that interconnect in a very complex but in a very efficient way. So if we look at a modern metro area, really what we're talking about is we might still have a central city core, but we also have these emerging places like Buckhead and others that are developing in their own right as major urban centers. Then you have all these little villages and towns, or they can be neighborhoods. You can think of them as regentrified neighborhoods. The question is, how do we connect them? Well, rather than thinking of a hub and spoke, we still will have some major trunk lines, but we need to think much more creatively about how we develop these connections. And sorry for the very sort of kindergarten-like design here, but I'm working on it, and our graphics artist at Reason Foundation, I'm in the queue, I'm at the bottom of the queue, so he hasn't gotten to it yet. But the point here is that we need to start layering within this network a more robust road system that has higher capacity, but we're not talking about capacities necessarily at the level of major interstates. One of the neatest ideas I run across in this literature has been something called a queue jumper. And the idea of a queue jumper is, think about a four-lane road, a four-lane road, 2 lanes going one way, but it's a local road, it's an intermediate road. And that if you think about it, and actually this was great yesterday when we were driving because we were just stuck in traffic going on these local roads and light after light after light. We wanted to go from downtown to Buckhead, but we had to go through probably 15 or 20 lights. Here's the question. Why, if you're going to Buckhead, do you have to go through any lights? Is there a way we can use engineering and design to circumvent that? The queue jumper is a concept where you do that. Essentially, you just let the through traffic jump over those intersections. Now, actually, from an engineering perspective, it can be done, and but you can design it so that you can create more throughput for those traffic that's moving in a different, that's going beyond that intersection. And the point is to jump over the queue. So there are flyovers. You actually take people up and over, or you can go under. That's another way you can do it. But there are also other more existing technologies. I've got to stop here, so I'm not going to go through all the other stuff. But the other thing that you can do is increase traffic light signalization. There were clearly many traffic lights that were not optimized yesterday. When you're sitting at an intersection, no one's crossing, and you're sitting for a good 30 seconds, something is not designed properly. And in fact, one of the most cost-effective ways we can really tackle congestion on local roads is through traffic signal optimization. When I was in London, England, I was at a tour of the traffic control system there. They have 6,000 traffic lights. 3,000 of them are networked into their signal optimization network. And the whole traffic control center, they have these huge screens where they've got the entire road system, and they track traffic volume and density. And they will know when there is an accident. They can see where the traffic's going to be backed up. They can make minor changes in traffic signal. It could be 10 seconds, and they can find that they can end up dramatically increasing speeds by the network effects of integrating all of those lights and calibrating them based on densities. And it's actually, it sounds expensive, and it is, but it's actually more cost effective than many other things. But anyway, I've got to stop.